casting clouds. Over the past decade, arguably since the Rodney King trial, of which you can see this still, image and video documentations of violence have gained an increasing evidentiary value. Thanks to the open source intelligence tools, an image posted on social media can be located in time and space, its pixels can be measured, its frames can be pulled apart, its truthfulness can be examined against other images, and eventually can be used to bring accountability. Images of clouds, carcinogenic plumes, chemical gases, or smoke from fires are hard to interpret. From within, these clouds appear as a kind of a fog, an atmospheric blur, if you like, fast-moving and morphing. How can we use such image and video documentations to search for accountability? Perhaps for the service of what Ishil Mende had foregrounded as the universal right to breathe. In this talk, I would like to share two types of architectural and investigative models that I've been developing to this end with my colleagues at Forensic Architecture around two cases. The case of the Beirut port explosion on August 4th, 2020, where we worked with tens of images posted on social media, and the case of Plaza de la Dignidad in the 2019 Chilean uprising, where we worked with a single footage, a single camera. So in a way, two models have a very different kind of a base. One of the earliest documentations of the explosions that shook the port of Beirut on August 4th last year was a photograph posted on Twitter showing a smoke plume rising from the warehouse. Examining it closely, we identified the location of the source of the plume. And it was kind of like on the northeast side of the warehouse. Then we located the camera cone of vision and the position of the photographer in the city. And then we used all these to cast a model of the plume at its source in our 3D model, in a 3D kind of an environment. Smoke plumes are continuously transforming and have a unique shape at every moment. And so we realized we can actually use them to synchronize the wide body of image and video documentations that were posted online. For example, we could identify that this image was shot around the same time of another video, this video taken from a residential tower building to the west of the kind of like the original photograph. Both show the same source of fire clearly on the same side of the warehouse. Another video taken from near the St. George Hospital provided 10 minutes of uninterrupted footage of the warehouse. For example, it captured the change in the color of the smoke plume from a kind of like a lighter color to gradually something much darker and much thicker. It also showed and kind of captured the appearance of a new smoke plume, which was on the other side, the opposite side of the warehouse. And it was a kind of a smoke plume that had a different texture. It had all of these sparkles in it, which would kind of like, would then correspond to fireworks, as we know. What I'm showing here is a kind of a polyperspectival model grounded on residents and visual testimonies from a residential house, for example, here, from a bar, and the kind of like the most west side of the warehouse, from the port, and further back, actually, from the sea, and a kind of a jet ski. So the model kind of pieced together these different kinds of perspectives. Here, because of the distance, it's the only point actually that we can see the ammonium nitrate cloud in kind of like within the frame of the picture, all fitting. In our model, we use situated images and video accounts of witnesses to build the smoke plumes with their distinct source, shape, and color. This level of detail helped provide indications as to the arrangement of goods in the warehouse, the way the fire developed, and the layout of what was stored inside. In Chile, we built an entire model from a single video, from a single perspectival point. A group of artists who run Gallery Simo have been live streaming footage from this camera 24/7, starting from the second day of the Chilean uprising in 2019. We sought to focus on its streaming from the 20th of December and plot all clouds of tear gas registered by this camera on this day. We confirm the time code of the camera using the length of the shadow is cast on the roundabout. We noticed the first tear gas cloud at 5:50 p.m. on a traffic island where some protesters started to gather. We marked the extent of the cloud with a kind of a frame, as you can see in this image. We marked the approximate location of the canister with a small cross, and then we labeled it in our timeline. We developed an automated logic for detecting the clouds throughout the video as the kind of like as the hours passed and the day unfolded. So the pink clouds are referring to the clouds the pink markers are referring to clouds of tear gas. For example, when protesters occupied the center of the roundabout, the police responded with an armored vehicle, a tear gas armored vehicle, in fact, which circles the roundabout. And you can see this cloud of tear gas that's just kind of like that, just blankets and sweeps over the space of the island. The second vehicle, and then the kind of like the police escalation of its use of tear gas around 8:30 p.m. So for about 10 minutes, the use of tear gas is escalated to such a degree that the entire population, like the roundabout, is evacuated. This is cloud 476, for example, appearing at 8:32. This is cloud 486. This is cloud 529. We developed a model of Plaza de la Dignidad using this footage, and we plotted the location of tear gas canisters accurately within the model in space and with a kind of a time code. These are the locations that you can see in pink. We worked with scientists from the Imperial College to simulate the airborne movement of particles in the space of the roundabout, cast them as moving point clouds, and respond and make sure that kind of like, and do this in response to using meteorological data from the day, for example, temperature, wind direction, so on and so forth. The wind carries the CS particles from the southwest to the northeast across the roundabout. The surrounding buildings generate irregular turbulences that carry airborne toxins into the larger neighborhood, and eventually we deposit them on the ground. Our simulation allowed a reliable measurement of the contour of the clouds and their shape, as well as their levels of concentration. And so what you can see in this image, the blue are the clouds, and the kind of like the marker on the ground is it's showing levels of concentration. And it was kind of like here that we found our hook. That our study showed that at a sample point in the roundabout, the concentration of tear gas reached toxicity levels of 40 times the allowed limits by the Chilean Police Manual for Cloud Control for a total duration of 185 seconds. In my contribution today, I share two kinds of casted cloud. The one that helped piece together tens of perspectival images to make a kind of a collective account. So so this is a kind of polyperspectival model, if you like. And the one in the form of a moving point cloud, anchored in data from a camera footage in the field. A cast in a way that links the witness on the ground with the scientist in the laboratory. Clouds leak out of the frames of images, and they are the epitome of transformation. Yet, it is possible to cast them in their place and bring accountability around them by piecing together testimonies from within